Now, so here the object is synchronous motor, power expressions and problems. Here, expression for power developed, maximum power condition, problems solved on power developed. So, the power equation is Pm is equal to EB V cos theta minus alpha by Zs minus AB square cos theta by Zs. So now maximum power. So can we find out the maximum power? So for that, the above equation we can derive the power with respect to the alpha. It is alpha is load angle. Here the load angle is varying with respect to the load. So here the derivation is the power derivation with respect to the load angle. Then here the maximum power condition is dpm by d alpha is equal to 0. So that is d by d alpha within bracket eb v cos theta minus alpha by zs minus eb square cos theta by zs equal to 0. Here alpha is, here they are eb square cos theta is constant, so it is 0, it will be 0, and the only thing is here abv cos theta minus alpha by zs, this derivation will get a sin theta minus alpha equal to 0. That is the derivation. Now here from this, so you can get sin 0, how much? That means 0 degrees here. So theta minus pi equal to 0 here. So theta minus alpha is equal to 0. That means theta is equal to alpha. So here the maximum power developed, when the maximum power is developing, theta is equal to alpha. That means, so here impedance angle or internal angle equal to load angle. Impedance angle equal to load angle. That is the equation for the maximum power condition. Now when theta is equal to alpha, when theta is equal to alpha, maximum power developed for phase Pm maximum, that is V EB V cos theta minus pi. If here pi alpha is nothing but theta, substitute here this Zs minus EB square cos theta by Zs, then we'll get, so EBV by Zs minus EB square cos theta by Zs. This is the power equation, and EBV by Zs minus EB square RA by Zs. So if RA is neglected, so here RA means armature resistance is neglected, the maximum power is, that means RA is negligible. The formula is for 3-phase power, the maximum power is equal to 3 EB V sin alpha by x. 3 EB V sin alpha by x. This is the maximum power developed in the synchronous motor. So now we go for problems. A three-phase 400 volts 50 Hz star connected synchronous motor has a full load line current of 68 amps. The synchronous impedance of the motor is 1.61 angle of 82 degrees ohms per phase. The motor is working at a leading power factor of 0.9. Find the induced EMF and the total mechanical power developed. So this is a question the given. Now the solution is the supply voltage VL, that is equal to 400 volts, and phase voltage V phase, that is equal to 400 by root 3, that is nothing but 230.94. Here cos pi is 0.9. Now pi is equal to cos inverse 10.9, that is equal to 25.84 degrees. Here the synchronous impedance 1.61 angle of 82 degrees, that is nothing but 0.224 plus j 1.594, and RA is 0.22 ohms for phase. Now XS is 1.594 ohms for phase. So here impedance angle theta is equal to tan inverse of 1.594 by 0.22. That is nothing but impedance angle theta is equal to 82.12 degrees. So here theta is 82.12 degrees. Impedance drop or impedance voltage drop, that is ER equal to IAZS 68 into 1.61, that is nothing but 109.48. So here by applying cosine rule, the induced EMF for phase is, so here EB is equal to under root of V square plus this is ER square. So ER square minus 2V ER cos theta plus pi. So now that is equal to, by substituting V and EB and theta and pi, so we get the induced EMF for phase is 284 volts. The line value of induced EMF, that is here root 3 into, if they given 3, that is not correct, root 3 into 284, which gives the 492.4. That is the voltage for line induced EMF. Now by sine rule, sin alpha is equal to E on sin theta plus pi by EB, that is equal to, so 109.48 into sin 107.96 by 284. Here sin alpha is 0.360, alpha is 21.51 degrees. So mechanical power developed PM is equal to EBV cos theta minus alpha by ZS minus EB square cos theta by ZS. So now by substituting the values EBV theta alpha and ZS, if we get the value is, the power mechanical power is 39.293 kilowatts. So here now go for the problem 2. So I'll read once again the problem. Here the excitation of a 415 volts 3-phase delta connected synchronous motor is such that the induced EMF is 520 volts. The impedance per phase is zero point 0.5 plus J4 ohms. If the friction and iron losses are constant, 8500 watts, and calculate the maximum power, line current, and power factor of motor. So what they given, line voltage 3-phase delta connected, and the impedances for phase is 0.5 plus J4. Friction and iron losses are 500 watts, and maximum power output is, find the maximum power output and line current and power factor of motor. Here the solution: 3-phase delta connected synchronous motor. For delta connection, the line voltage is equal to phase voltage. Line voltage VL, that is equal to 415 volts. For phase is, here this is the line voltage 415 by root 3, and induced EMF is 520 volts. Now ZS is 0.5 plus J4 ohms, and that is equal to 0.5 whole square plus 4 square. Now that is 4.03 ohms for phase, and the impedance angle is equal to theta is equal to tan inverse of 4 by 0.5. Now that is equal to 82.87 degrees. Then the friction and windage losses equal to 500 watts. For maximum power developed, load angle is alpha is equal to impedance angle. Here load angle alpha is equal to impedance angle. There is nothing but for maximum condition. So alpha is equal to theta, and is equal to 82.87 degrees, and the resultant for phase is, ER is equal to under root of V square plus AB square minus 2VEB cos alpha. That is nothing but under root of 415 whole square plus 520 whole square minus 2 into 415 into 520 into cos 82.87. That is 623.87 volts. Resultant voltage is 623.87 volts. So now armature current IA is equal to ER by ZS, that equal to 63.74 by 4.031, is equal to 154.74 amps. So line current IL is equal to root 3 into 154.74. Here the line current and phase current both are different. Why? It is delta connected. Delta connected, phase voltage and line voltage both are same. So that is 268.02 amps. For maximum power developed per phase is, so that is P maximum, mechanical power P maximum is equal to ABV by ZS minus AB square by ZS cos theta. That is nothing but, here by substituting ABV ZS and cos theta will get 45209 watts. And here maximum power developed for 3-phase, 3 into 45209, that is 135627 watts. So the total power output is power developed minus iron and friction losses, that is 135627 minus 500, that is equal to 135127 watts. That is the total power, and total copper losses are in three phase, that is equal to 3 into I square Ra, that is equal to 3 into 154.74 square into zero point 0.5, 35.917 kilowatts. So total input power P is equal to mechanical power developed plus copper losses. Now 135.627 plus 35.917, 171.544 kilowatts. That is the total input power. Now the power is equal to root 3 VLIL cos pi. Now cos pi is, so here power by root 3 VL IL. Here by substituting VL, IL and power values, we'll get the cos pi, that is equal to, so 0.89 leading power factor. So here we have discussed the following expression for power developed and the maximum power conditions. So problem solved on power developed. So this is the